version. And, okay. Can you see the screen? Is it okay?
Yes.
Okay, great. I'll just try. And it's on full screen now. Is that okay?
Yep.
Good. Right. Then I'll start right now. Okay, so this is the third part of a series of talks that I've had. And what I'll do first is summarize very quickly the first three talks. So the first one, which was about 10 days ago, I think, was called Exploration Risk and Resource Assessment. And the key topics there were play-based exploration and petroleum systems. We talked about structured workflows with standardized processes and guidelines. I showed, for most of the talk, I showed best practices. And for that, one of my favorites is a mega regional study of the Pannonian Basin that was done by NIS, the Serbian oil and gas company. And at the end of this talk, excuse me, I mentioned the transition in a way from deterministic to probabilistic assessments. And that's a topic that I'll continue with today. In the second talk last week, excuse me, I talked about block ranking. And the key point there is that sometimes in reality, you do not have sufficient time or resources to follow the best practices that have been shown by NIS in the Pannonian, for example. But sometimes we have to be able to react very quickly. And so I showed an example of a review, a block ranking review, where 40 blocks in a country had to be evaluated and ranked in 3 weeks. And the key points there were the definition of risk models and risk factors, the need to establish an expert level team to do this. This is a serious team effort. And in the example I showed, there were about 5 people working nonstop for 3 weeks to do this. And then I introduced very simply, Dimitri, the co-author, is actually the expert for this, but I just introduced in very simple terms a multiple criteria decision method, which sounds very theoretical, but then I showed with an example, with a case study, how this works. So multiple criteria decision method with weighted scoring, and it might sound theoretical, and but it's very practical. It's really convenient. So today, I'll talk in part 3. The topic is exploration portfolio management. A very quick summary of the lessons that we learned from talks 1 and 2. And then the missing component is we need to move from the play. So far, we've only looked at play scale risking to prospect risking. Quick look at that. And then I'll talk a little bit about decision criteria and communications. And this is summarized very nicely by a dashboard concept. And what I'll show here has been developed by Dimitri. And you'll see this is a really very easy to understand, a very practical approach. So just have a repeat first. The first part was exploration risk and resource assessments. The first part there was play-based exploration. And because this is very interesting for students, this was originally built for the APG Imperial Barrel Award. And this is a very nice document, and this is the starting point, a concept that's very widely used in the industry. So have a look at this. You'll see the role of play, prospect risking, the role of petroleum systems analysis in this. I also introduced quickly petroleum systems modeling and showed the necessity to go back and go out to a basin scale and develop as much understanding as possible of how the petroleum systems work, regardless of what data is available. The key point here, one of the key deliverables from doing the petroleum systems modeling is better understanding of the risks. And these risks can be summarized: source risk, migration risk, reservoir risk, seal and trap risk together. And these are the exploration risk factors. They're all dependent on our understanding of how the petroleum systems in a basin work. And we define so-called exploration risk models. And this is a very important concept, to use standard risk models. And typically, companies have corporate standard risk models. And this is essential. You have to use the same risk model to support play and prospect risking and ranking. Otherwise, you'll be comparing apples with oranges, pears, etc., and you won't get anywhere. So standard risk models, they're quite simple, very commonsensical, but to have a standard is essential. That was the first talk. Then summarize key points from the second one, which is the block ranking. And the key points there were, you need to have an experienced team, an assessment team. And in the case study I showed, we had an experienced explorationist who developed the strategy and guided the process. We had a sequence stratigraphy expert, because the work included looking at the seismic data in a data room, and the skills that a good sequence strat expert has are essential. They look at the seismic, and in their heads, they look at geology. It's really important. Petroleum systems analysts, because we need to develop a standard risk model, and we need to have somebody who looks at the different petroleum systems related risks. And a critical point too in this assessment team, regional geological experience. This is essential. You need a lot of people say you need the old guys for this, and you need to have this regional geological knowledge. Then in data room sessions, you can review each block. We look at the risks. We look at the regional geology play risks. We look at what has been done for lead and prospect assessments and volumetrics. And then we use a block ranking methodology, the multiple criteria decision method with weighted scoring. We use the standard petroleum systems risk model. We develop block ranking criteria. I showed a summary of the block ranking, and we can also use that to rank different areas, different parts of the basins once we have the block ranking. So I showed an example from an actual study there. These are the steps in the multiple criteria decision method, and we looked at these twice in the second call: framing the problem, what are the criteria, what are the weights, what are the ranking candidates, assigning scores, calculating the total score, and then we have information that will help us to take a decision. So first, this looks very theoretical, but then I showed the practical application. And these, on the left-hand side in the box, you can see an example of block ranking criteria and a weighted score. So what are the criteria? Here are the criteria. Typically, we always have one standard criteria, and you can see the weight here. This is a very important one. We assess the expected or assessed hydrocarbon volumes versus the chance of success. So this is easy to understand. We might be looking at, for the biggest prospects, the biggest possible volumes, but maybe they have a low chance of success. They're very risky. And we also talked about that being part of a strategy. That is important. A strategy that a company has. You might be interested in, you don't want to have the risky stuff, and you will accept finding smaller fields and being more successful. So that is a corporate strategy, a very important point, and you'll see a little bit more about this later on. So for each project, you will have different criteria, and in the project we were looking at here, we were also interested in the upside potential. So this is additional long-term potential that has not yet been assessed, but we might know, well, there are potentially some new plays. They could be new deep plays, and we think that is positive for the block. If the block has potential from new plays, then that is a factor we want to include. We give it a 20% weighting in here. Also in this case, though, there was a lot of pressure on the client to also have prospects which can be drilled very quickly, and they might even enable them to ramp up production in maybe even 2 years. So this is also, in this case, an important point. And we looked at accessibility because here we have a lot of problems with access. We can only shoot seismic in very limited periods. And so this could be in the tropics, for example, or in the Arctic, where you have accessibility problems. And then you can see in this table, you can see this is a preliminary table that is built in Excel. And you can see on the vertical axis, chance of success. On the horizontal axis, the assessment of the resources. And then you can see different categories in here. So over here in number 1, we'll see an area where we have a low chance of success and low resources, not very attractive. And as we go over here, we have an area where we have a high chance of success and possibly also very large resources. And this is the scale. You can see the ranking that we want to develop. So each block gets a ranking. The results look like this. So this could be the area, and you can see the red here. So here is the weighted score block ranking criteria, and here you see number 1. That doesn't look very good for various reasons. So you can always look back in the database and see, well, why is the ranking so bad? But you can see one block in here, that is the block number with the category 5 over here, this one. This is very highly ranked for a combination of reasons. There are always a combination of reasons here. So that's the point. That was the block ranking summary. So you can see again where the multiple criteria decision method comes in. And now we'll just have a quick look at exploration portfolio management. So what are we doing in exploration? We have what is often called an opportunity funnel. We all know how this works and what this is like. We have a lot of potential prospects or leads to start with. So you could start with a review of a basin. You can look at the data. You can look at this conceptually as well. You could say, what is the structural style? Maybe I'm working in a thrust belt. So I have an idea of the type of traps or leads that I might find. So this is the first part. And this is also connected to a resource assessment. So in this stage, we can assess the undiscovered resources, even if we have very little data. We'll have higher uncertainties, but we can do a very good job. And this is a separate topic, resource assessment. And we recommend, for example, guidelines from the Norwegian Petroleum Directorate for this topic. The next stage we're here in is where we look at the leads, develop them into prospects. We do more interpretation work, more assessment work, and we then want to reach the stage where we have a drilling decision. We then go through appraisal and development planning, etc. So this is the funnel. And we might start, many major international companies have databases with prospects, for example, a prospect database, global database with tens of thousands of prospects. And they all need to be ranked using a standard. The process is obviously not just a simple funnel, a one-way track. We all know what it's like in reality. A project will start, something will change, it'll stop for a while, it might restart. And so managing the prospect portfolio is also an iterative process. We repeat this all the way through. Interpretation and mapping, petroleum systems, play risk, prospect risk and ranking, and the valuation part, the economics. And we go through again, what we're actually doing is using an exploration portfolio management system to manage this process, but it needs to be controlled. You need to have standards in the process. Right, what we also looked at when we started with the first talk is a schematic, a very simple structure that we all use naturally. Is to start, we have the data management. We also talked about the situation in Ukraine briefly, which is quite difficult because there is a huge amount of legacy data. A lot of it is not even digital. And so it is a massive effort to filter out the data that you need. But an important point too is that following the structured process, for example, doing the petroleum systems modeling, helps you to select the data that you really need. And you might have thousands and thousands of wells. We looked at the project in Serbia with 3,000 wells in the database. In the end, only about 500 provided meaningful data for the stratigraphic interpretation. So this is an important point, structured data management. We looked at the geophysics and the geology work, interpretation, etc. We looked at petroleum systems assessment, and then we looked at the transition you can see here from deterministic modeling from the G&G work into a probabilistic approach. And the first part, what we're doing here is we looked at play and block ranking. And we also, at this point, can assess the undiscovered resources. This can be done. So we can end up with maps like this, so-called play chance maps. And important point here, though, is this transition to a probabilistic assessment. So undiscovered resources are probabilistic. It doesn't make any sense to look at one value because you might have in one block a big value, in another block a big value. But if the uncertainties in the data are totally different, the risks are different, you need to have this information as well. One number is not going to do it for you. The next, and so we looked at this. This is an example, industry practices, play chance mapping. You can see here we've just delineated them for each block here. This is done by a regulatory authority. And you can see an example here, BOEM is the US offshore agency. And this is their assessment of the undiscovered resources. So you can see for each of these, in this case, they're only showing large areas, but they also always have very detailed analysis. And so the play risk analysis enables them to define where the resources are. So you can, obviously, you could do exactly the same for Ukraine. You could risk every play in the country, map it, build a play catalog, and you could then simply have, for example, a colored map like this. Where are the best plays and where are the best assessment units? This is an industry standard process. Now we go to the prospect. So we have local scale geologic risks. We always have the play scale and the local scale geologic risks that we need to understand when we interpret the prospect. But we also have a probabilistic aspect. So you tell the exploration manager, Well, you know, if we drill here, we might find 1 million barrels. And obviously his question will be, well, what is the chance of success? What is the probability here? Is it 50-50 or maybe only 10%? And without that information, which you can only get from a probabilistic assessment, you cannot fully risk or rank the prospects. And then we'll see too, this is what we need to do first. Then we can go into portfolio management. We can build a database, but the first part is we need standards for prospect risking. So the industry standard approach, once again, you can see here in the shell play-based exploration guide, is that we always subdivide the risks in exploration into a play chance risk. This is often called, different terms are used. This is often called a regional risk or a shared risk. A shared because it's shared by all of the prospects in the play. It's something they have in common, the play risk. Then we have the prospect level. So this is separate. You might remember in the, if you watched the first part in the Pannonian Basin project, this was at first just the play risking was done. A play risk analysis is first. Later on, we go in and look at the prospect risk. This is also called a conditional or a lead or a local risk. So you'll often see the term conditional because it is conditional on the other risks in the system. Then we can see what we often do is take the risks, in this case, trap, charge, reservoir. We stack these, we multiply the risk factors together, we develop composite risk maps, and then we can combine the play and the prospect risking to define what is often called a total geological chance. Different terms are used, geological chance of success, etc. And this is a standard approach that we use to rank blocks on a play scale or to rank the prospects then. So we need to move then to a stage, and there is a lot of work involved in risking prospects and doing the volumetric assessment. And once again, just showing one value is not meaningful. We have a lot of uncertainties, and we need to take these uncertainties into account. We have the trap geometry, and the traps can be very, very complicated. They can also be very difficult to assess because you might be looking at unconventional types. Like in Ukraine, you might be looking at tight gas, maybe tight oil, and this makes it more difficult. It's a pretty difficult job here to assess the geometry. What is the extent? How to define that? And that can be done. So we've also done this for projects there. Then mapping the reservoir parameters and the extent. Ideally, you might have 3D seismic to do this, and what was initially a single reservoir or a single target might then be resolved into different segments, different parts with different qualities. We need to assess the seal capacity, column heights. We need to assess the hydrocarbon composition. What can we expect, oil or gas? This is where we go back in and look at the petroleum systems modeling. And then for the prospect chance of success, we need to assess what is the chance of the presence of the trap, reservoir presence and quality, top and lateral seal adequacy, charge probability. So we end up with a risk volumetric assessment, geological risk volume uncertainty. We need to be able to handle complex geology, especially here with multi-segment traps. Performance tracking is important because we can compare, and this should be done as a standard part of a process in every company, so-called performance tracking. What are our predictions? What are our results? And that is part of a database. So in Norway, for example, the Norwegian Petroleum Directorate have performance tracking data for every well that has been drilled in the country. And they know that predictions are probably always 2 to 3 times as high as what was discovered. And that is important because they are asked to predict or to assess predictions that are made of the potential resources in the country, and they have to know how good are the company predictions actually. There are many reasons why they are not very good. So, and performance tracking is a very interesting topic here. So then we go and we complete the prospect evaluation. We have risk, volumetrics, probabilistic scenario analysis, and dependency models. We understand what are the dependencies between, for example, between different risk factors and parts of the prospect that we're looking at. So a lot of work, and this feeds into the prospect risking part. So for this, for prospect ranking, we can also use an approach which is comparable to what we use for the play risking for the block ranking. So you can see here's another example. Now you'll see this is easy to understand. Once again, we have hydrocarbon volumes versus chance of success. And this is the definition. Negative, what are the negative factors? What are the positive factors? And what is the weighting? In this case, 40% of the final ranking is dependent on this. Then we have the key petroleum systems element risks. We have upside potential. This is interesting. This was the same that we had for the block ranking. We want to know what the upside potential is, maybe in undiscovered plays. What is the positive factor here? You can see additional potential for secondary well targets. So this is a factor. Then what risk or what problems do we have? We need to take that into account. Mapping uncertainties. It could be lack of data. It could be complexity. And another factor is proximity to existing discoveries. So if we already have a discovery in a comparable situation, that is also included in the weighting. So this is the total 100% of the weighting factors, and this could be used here in this simple example on a specific play here to risk and rank the prospects that we're looking at. So we can see this, we do this on a play scale for block ranking, and here we're doing it for prospect ranking. The next part is what is just called here the techno-economics. And so obviously what we need to consider is the economics. That's very simple. We might have, anything can happen. You have 1 billion barrels somewhere, let's say a water depth of 1,000 meters, and it's close to existing facilities. Or you have the same number and maybe the same level of geological risk, but it's deep water, it's hundreds of kilometers away from the nearest facilities. So obviously there is a huge difference in the economic risk, and that has to be taken into account. So this is a topic that Dimitri will discuss in more detail in a talk this afternoon at 4 o'clock your time. And you'll see this is an essential part. You cannot look separately. And often as geologists, so I'm a geologist too, we tend to think, oh, we just look at the G&G work and the geological risk factors, but that doesn't work in reality without taking the economics into account. You need an integrated solution here. Okay, so what I'll show here, a very nice summary of the points that I've just introduced. This is a prospect ranking dashboard. So what's a dashboard? That's something in a car. We have instruments, we have a speedo and the rev counter and lots of warning lights, etc. And that gives us an overview, a single overview of all of the critical information that we need. And we can see this is really crucial. This is really important because you might have a lot of technical people, maybe even hundreds of G&G experts working, analyzing, looking at the plays, looking at the prospects, doing all sorts of work. But in the end, somebody up in management will have to understand what is being done, and will have to make decisions on drilling priorities. And so this is why This so-called business intelligence dashboard is not just a pretty picture, it is critical for the quality of the decision. So in the background, we have a database, the prospect database, all of the information that we've done following the play and the prospect risking is stored in a database. That is critical. It needs to be a database. You can't do this in Excel and stuff like this. For example, it needs to be secure. The information in that database is strategically important for the company, and it needs to be secure. You can't just have hundreds of people messing around in the database. You need approval processes, etc., backup systems, and this has to be integrated in a single database. What you then do, because you're following standards, you can calculate the scores, you can visualize the results, and this is how the technical staff and the technical experts can communicate the conclusions to management. So this is how management and technical staff can communicate. So we'll just have a look at a few features. This is a map of the world. This is for maybe for a company that is exploring globally. You can see the prospect locations. This could be exactly the same if you were to do this in Ukraine. You would see all of the prospects that you are looking at. And we have clients, as I said, who have thousands and thousands and thousands of prospects in this database. So you can apply filters, etc., to extract the data, look in a specific area. This is normal, but you need to see where things are. This is always the same. Then you can see here the custom ranking criteria and weights, and you'll recognize this now. You can see here, for example, a setup has been used where the volumes and the chance of success, they have a weighting of 30%. So this is always specific for a company or a project. You can see here up downside potential, expected monetary value, target hydrocarbon quality, exploration maturity, and here we have 6 topics. In the previous one that I showed, we had sometimes 4, sometimes 5 topics. This is standard. So you need to have a standard ranking system. Then you can compare the prospects. Then the ones we saw here, this is the one that we've seen already in the Excel table, hydrocarbon volume versus chance of success. So once again, you can see here are the mean resources on this scale. Here is the chance of success. And so we can immediately see, well, we have maybe some big ones in here that have good, very high potential in terms of volumetrics, and also a very good chance of success. Here we see all of the prospects that have been assessed. We can also see value, upside, downside. So when we start to look at the cost, for example, of accessing the hydrocarbons and producing them, that needs to be part of the assessment. Or we're in whatever, deep water versus shallow water, etc. Everything that affects the cost of accessing the resource. And then you can see here, one more thing here. You'll see this in a moment in more detail. Once again, we look at, let's just go back and look at this again. You can see the different colors. And these are prospects. This is, for example, whatever there might be 20 prospects in here. And this is a ranking. But the ranking is done according to the ranking criteria, according to all of the G&G work that has been done. And we can see what is important. So you can see big differences here. If you look at the volume versus chance of success, 30%, you can see big differences in here. In some cases, they'll have a strong effect. In some cases, they'll have a smaller effect, but you can see this immediately. Which of these factors is influencing the ranking more or less? This is very important. Then you can see down here a so-called risk appetite. This sounds a little bit strange when you hear it for the first time, but this is the strategy. This is where management can use information to assess the risk appetite. So what is their strategy? Is their strategy, for example, as a global exploration company, to look at prospects that have a very high risk, but also the chance of discovering big volumes? So whatever, we ExxonMobil looking at Guyana a few years ago, and so we might think, well, we have no clue at first, this is a very high risk, but if we are successful, the volumes could be very high. And this is the risk appetite. A big company will have a bigger risk appetite, and a smaller company might just say, well, I don't want, this is too risky, this is too expensive. I'm only interested in smaller targets that have a lower risk. And I want this system to provide this information. So you can see here, risk reward, and you can see as we flip through and look at different scales, and you look at the prospect ranking, this can have a drastic effect on the prospects. So now we go through here. You can see this little button moving over here. I'm moving across, changing the risk appetite, and you can see how the portfolio shuffles. We have one big one here, and Kimberly, this one's called, let's see. There are scenarios where it is now downgraded to number 2. So everything depends on the risk reward, but overall this one looks pretty good. But you can see you can have really big switches in here depending on the risk in the ranking and your risk appetite. So this is an important factor to consider this, and it's all on the one overview. So we can pick here, for example, we're looking at a specific prospect in here, and we can see here is the name, the country, the data, weighted score, etc. All the information is directly accessible. So we can also say, well, I just want to look at a group of prospects. So I've just selected these here, which I want to look at, and I can see where they are on the different tables in here. For example, volume versus chance of success. Only these ones here are highlighted on the map. They're all linked. This is very straightforward. So the benefits here are quite clear because there's a huge amount of information that is going into these decision systems, but you need to have the standards, you need to have the guidelines, and then you can do this. And obviously, management can look at this, talk with the technical teams. You have one instrument to give you unbiased information. It's not somebody just saying, oh, I think this one is good, we should drill it. You actually have data to support the decision. So as an example, this prospect here, we're just pointing to, you can see this looks very good. This has big resources, big potential. The chance of success is also quite good. But from an economics point of view, this could be very bad. And this could be anything. This could be cost of accessing, cost of drilling. It could be costs involved in the licensing, in obtaining the right to drill in a certain area. And so you really need to get these people together. You need to have the geoscience perspective and the economics perspective. So the conclusion here could be, if you are just the G&G, the geoscience expert, they will go for this. But the economics, after the economic risk assessment, they wouldn't even look at this. But if a manager has access to the full information and very simply provided through a dashboard system like this, they might say, well, I really like this one. This is too big to miss, but I need to check very closely, where did the costs come from? And they could, for example, come from the licensing terms. So then they might go back in and say, well, I'll have to go and renegotiate these terms. I need to look at this. So you see the value of having this information here together. So how is this implemented? in companies. So, we don't just get to the business intelligence dashboard automatically. We have a few groups. We first have asset teams. So we have all of the geoscientists, for example, the economists, the specialists, they are all working, and many companies have an asset team structure. So different areas, for example, are assigned to different teams. So they're all working here. This could be hundreds of people. Then you have an internal, but it can also be an external or a combined peer review team. So you need to have a group of experts who supervise the process and can approve or reject an assessment. So one asset team here says, "Oh, I've done this work and these are my conclusions," but they have to go through what is typically called a stage gate process. And this is the team that says, well, no, we really need to do more work, or we really need to acquire more data before we can go to the next stage in the work. This is the peer review or quality assurance team. Then everything can be stored in the database. This is the database I've already described. And once again, it cannot be a bunch of Excel tables flying around all over the place. And this needs to be very rigorously controlled. You then have the decision maker. This could be exploration management or a board, a team. They review the results. They ask for clarifications. They select the prospects based on information that they can get. And if necessary, for example, they could say, well, what happens if my risk appetite changes? Let's follow a different strategy. Let's take more risks and see what happens with the prospect ranking. And so here you can see how the business intelligence dashboard fits in between the corporate risk resource and value database and how management can communicate them with the asset teams and the peer review teams. They're all sharing the same knowledge. The underlying part again is to understand the G&G work and the need, and this is a big step when we go to play risking and to prospect risking. We have to work in a probabilistic manner. That's the only way we can work. We need to define standards. We have risk models. We have peer reviews, internal or external peer reviews, and this enables us to develop a probabilistic database for the company. So that's it. Just one final part here for all of the deterministic geoscientists. There are a lot of interesting books. There's one here I like a lot. And why do we need this probabilistic stuff? And the title of this book is perfect. Why can't you just give me the number? So the exploration manager might say, well, I just want a number for this. I want the volumetrics for this and the volumetrics for that. And then I can compare them, but you can't. You've seen they're very complex. There are multiple criteria involved in the decision process. And this is the topic of this talk here. So thanks very much for your interest. And you can contact me with this email address. And also, again, for the next part of this story, have a look at Dimitri's talk later this afternoon, and you'll see the next phase and more information on prospect value assessment, because we're not just interested in the volumetrics, we're interested in value. So that's the final slide. Oh, just a sec. Okay, thanks very much. And if there are any questions.
You can open the group chat. One of the participants has a question for you.
Okay, oops, I've got too many. I have to find the right box here. Sorry, I've just got too many here.
Or I can just read it for you.
Yeah, maybe if you could do it. I just need to.
This is from Ivan Karpenk. Thanks for the great presentation. Can you tell us what soft you used for prospect ranking? Is it Geox?
Yes, it is. It is based on GeoX here, the database, and that's the important point here, as I mentioned, is the database. You saw in an example, and I'll just look at the overview here. You saw in this slide that I showed that you can do this in Excel tables, and it's important to understand exactly what is happening. You don't need a black box, but it's also important to have a database to control this. If you're working in a company, if you're just working on your own, you could do this in Excel. But if you're working in a company, you need a database with all of the required functionality. And in the examples that I've shown here, this is done with GeoX. So this database here is a GeoX database. And the dashboard here is one way and a very nice way to extract information directly. All of the information that I showed here is extracted directly from the GeoX database.
And he also asked you, please tell us what means competition factor for ranking.
Let's just see. This was I think. Wait a minute. I'll just go back to. I think yes. Ivan might be referring to this one here, the competition, and that can be a factor. As an example, I've done a lot of work in East African countries, and there is competition between the countries. So they are doing this as a play assessment. They need to understand what do they need to do. For example, in Mozambique to compete with Kenya and other countries in East Africa. But obviously you have competitive aspects for companies. And so that could be, for example, competing in bidding for certain prospects, for certain blocks, etc. And there are aspects there that could be more or less important. So we had that, for example, in working with clients in block assessments. In one project, there's a major project, the project actually where we had the 40 blocks. One aspect there is what is the competition? So we were doing this for a client, and what are the client's competitors doing? And that was important because sometimes you could, for example, bid for work in a block to block the competitors. That can be an aspect. What is the value of bidding? Because I can keep a competitor out of there if I bid. That can also be a strategic aspect. So this has several aspects, the competition in here. I don't know if Dimitri is, I think he was on the call. Dimitri, if you want to add any comments to this or examples.
Yes, yes.
Okay, great.
That's a good question. That's a very good question, and we always get comments on this particular factor. And this can be anything that you define in your standards. Because first we need to ask ourselves whether big competition is a positive or a negative factor for our prospect. From the one hand, if competition is big, then you are likely to pay more for accessing the acreage. On the other hand, if we are talking about hot place, then probably that means that somebody knows something about this area, and this is why we need to be there as well. So in this case, high competition would be a better situation than a low competition. So really you need to define everything in your methodologies. Your ranking methodology is an important part of the story, and your dashboard does not exist if your methodology is not defined. So essentially you need to start with methodology and then go to visualizing the data.
Okay, thanks. And Hello, Ivan. Thanks for the questions too. Okay, so are there any others? Just let's see. So, oops. Okay, so this is Ivan's question in here. Okay. Good. So any others? Nope, probably not. So then thanks again for joining the call. Contact me if you have any questions and see if you can log in to Dimitri's call, which I think is starting in about 1 hour. Is that correct, Dimitri?
Yes.
Okay,
Well,
great, right.
look
Okay,
forward to see you all.
okay, thanks everybody. And thanks again for hosting the call again and for the invitation to present here. Thanks, bye. Bye.
Thank you very much. Have a nice day and stay safe.
Okay, thanks again. Bye.